So we've been dealing with simplifying expressions and our properties of exponential functions, and now we're going to get to the properties of powers and exponents. Now we're getting into functions. All right, so in functions involving radicals, radicals means your square root, your fourth root, your cube root, fractional powers. That's what radicals means. So you can always convert a radical expression to a fractional power. And a lot of times on the calculator, if you're graphing these or solving these, sometimes, especially if you get higher degrees, it's easier to switch them to the power, the fractional power. Now, the square root function or the cube root functions, a lot of times calculators will have those, but anything higher than that aren't necessarily built easily or easy to find in the calculator. All right, simplify and solve the following function. So this would be something like if I have f of x raised to the nth root of x to the n, all right, which you can write as. All right, those are what we mean by functions involving radicals. That would be a function involving a radical. All right, so something like f of x equals just a simple fourth root of x, which again, it's not necessarily easy to find the fourth root of x on the calculator. A lot of times it's easier, and when you get to calculus, you'll want to do derivatives, and it's actually easier to do a derivative using the power. So we'll switch to the power of the root, so it's exactly the same as x to the fourth root. And so if I wanted to graph it, that's probably how I'd plug it in, or if I wanted to solve f of 81, well, that would be the fourth root of 81, which is actually easier to plug it into the calculator, 81 to the fourth power, right? You just 81 raised to the 1/4. Make sure you're careful, though. You do put parentheses around your 1/4 on your calculator, and then your calculator should give you 3, right? If I take 3 to the 4th, that'll give me out 81. All right, another example of a radical function. So g of x equals 4x, the cube root of 4x, sorry, cube root of 4x. Let's write that better. All right, which again, this is a rational function, right? It involves a root. Sometimes it's easier, especially if we're going to graph this, to rewrite it like this. It also makes it easier to simplify. This, again, the hard thing that students will do here is they'll simplify incorrectly. So remember, the 4 is under the root, and so is the x. So that's why I put parentheses around. If you wanted to rewrite this, you could rewrite it as 4 to the 1/3 power times x to the 1/3 power. But again, I think it's easier in the first form I have there, but that's how it would simplify. All right, so sometimes this is the way it's easier to, if I graph both of those things are exactly the same thing, and it's actually easier to graph the second version than it is the first version. All right, so we'll find an example. G of 16 would be 4 times 16 to the 1/3, which would be, well, it comes out 4 because, right, 4 times 4 times 4 is what you get, but I'm going to write out what 4 times 16 is just so that we have the number 64. Alright, so 4 times 16 is 64. 64 raised to the 1/3 power is 4. So again, if you typed it in the calculator, just make sure you're careful. Make sure you'd put parentheses around the 1/3 when you type it in. Or if the calculator puts it up there, you're fine. If you've got an older calculator, though, make sure you always put a parentheses around the fractional exponent. Alright, f of x is the square root of x to the 5th, which if I wanted to rewrite that, that's x to the 5/2. Again, this is probably how we graph it. It's x to the 5/2 is a power function. And so if I wanted to solve f of 4, it would be 4 raised to the 5/2. And again, you can type it in your calculator or by hand. Remember, x to the 5/2 is exactly the same as the square root of 4 raised to the 5th. So that would be 2 raised to the 5th, which is 32. Right, but it should give you the same thing if you type in 4 raised to the 5/2. Just make sure you put parentheses around that. It should give you, I don't mean 35, 32. I said 32, but I wrote 35. Alright, so again, those are just some power rules. And powers just make it a little easier to deal with. Right? If we're doing stuff, if we're solving equations, if we're doing calculus on it, or if we're graphing them, or if we're plugging into the calculator, often it's easier to plug the fractional power versus the rational power. These are exactly the same thing. They mean exactly the same thing. All right, like I said, often it's easier to plug in the fractional power than it is the root, especially when we start getting to bigger functions where I've got bigger roots. It's often easier to plug in x to the 1/4 than it is to plug in the fourth root of x. All right. So again, that is what we'll be doing in this chapter. So we go to graph stuff and solve stuff. Often that's the process that we will use.